This LOS is calculate and interpret the expected value, variance, and standard deviation of a random variable and of returns on a portfolio. Portfolio expected return. Portfolio return is a weighted average of the returns on the securities in the portfolio. So it's easy, we're just doing a weighted average calculation. Similarly, the expected return on a portfolio is a weighted average of the expected returns on the securities in the portfolio using exactly the same weights. So when we have estimated the expected returns on the individual securities, we immediately have portfolio expected return. So here's an example. We have three assets. One is the S&P 500, two is long-term corporate bonds, and three is the MSCI Europe, Asia, Far East, which is another stock index. And so we have our weightings here, 50%, 25%, and 25%. Of course, that's going to add up to 100%. And then we have our expected returns, 13% expected return on the S&P 500, 6% return on the U.S. long-term bonds, and 15% on the MSCI Europe, Asia, Far East. So how do we calculate the expected return on the portfolio? It's weight 1 times expected return 1 plus weight 2 times expected return of the second asset plus weight 3 times the expected return on the third asset. So you can see 0.5 times 13% plus 0.25 times 6% plus 0.25 times 15%, and we're going to get 11.75%. So the expected return, weighted average, very easy. Now we're going to look at the variance of a portfolio of assets. So the standard deviation of a portfolio is the square root of the portfolio variance. Correct. Standard deviation is always the square root of the variance. Okay. So here we have the formula. And we can see that the formula for the standard deviation of a portfolio includes covariance. Here's the formula. Weight 1 squared times variance 1 plus weight 2 squared times the variance of 2 plus 2 times weight 1, weight 2 times the covariance. Okay? And that's because we saw from that assets don't move in the same direction all the time. So that when we calculate the expected return, that's easy. We're just using the weighted average. But when we calculate the variance or standard deviation of a portfolio, we need to include this covariance term. Now remember, we can also rewrite the covariance as the standard deviation of x times the standard deviation of y times the correlation coefficient between the two. So now I can rewrite the formula for portfolio standard deviation to include correlation. So I've rewritten it here. You can see I've substituted the covariance for standard deviation of 1 times standard deviation of 2 times the correlation. Okay? So any correlation less than 1 and the portfolio standard deviation will decrease. Now a special case, if the correlation is 1, then yes, the standard deviation for the portfolio will just be the weighted average. Okay? So as I said, in the CFA level 2, they can expand the math to 3 assets. And that's the foundation for portfolio management theory. We always start with a 2-asset portfolio. Okay? So again, the formula for the standard deviation of a portfolio, weight 1 squared times variance 1 plus weight 2 squared times variance 2 plus 2 times weight 1, weight 2, standard deviation 1, standard deviation 2 times the correlation coefficient. Or again, the last 3 variables there, standard deviation 1 times standard deviation 2 times correlation, that's the covariance. The LOS does say calculate, so let's do a practice problem to check your understanding. The standard deviation of returns for shares of Oakmont Corporation and Sunrise Corporation are 14% and 12% respectively. If the correlation between the two stocks is 0.25, and a portfolio consisting of 35% invested in Oakmont and 65% in Sunrise, it has a standard deviation closest to A, 10.2%, B, 12.7%, or C, 35%? Okay, this is a fairly easy question again. It's very mechanical, but you've got to get your keystrokes fairly quick. And so you can see here's the formula for standard deviation of a portfolio, weight 1 squared. Well, they're giving us the weight 1. It's 0.35, so it's 0.35 squared times the variance of 1. Aha, they've given us the standard deviation. Remember, if they give us the standard deviation of 14%, the variance is 0.14 squared, plus weight 2 squared times the variance of 2, plus 2 times weight 1, weight 2, standard deviation of 1, standard deviation of 2, times the correlation. Okay, they gave us the correlation. And so if we work through all the math, we're going to get 10.2%, and so the correct answer is A. Easy question, but you can see you have to run through quite a few keystrokes on your calculator. Speed is a skill, skill gets rewarded. You want to practice this question a couple of times. Okay, here's a little practice question to test your understanding. A correlation matrix of the return for securities A, B, and C is reported below. So of course the correlation between A and A is 1. Between A and B is 0.5. Between A and C is 0. And the correlation between B and C is negative 0.5. Which combination of securities is the best for portfolio diversification? A and B, A and C, or B and C? Okay, pretty easy question. C is correct. The best combination of securities for portfolio diversification, we're going to look for the lowest number. And remember, correlation is moving from -1 to +1, okay? And as we lower the correlation, we're going to add the diversification benefits. And so we look, the lowest number that we have there is negative 0.5, and that's between B and C. B and C, correlation of negative 0.5, that's the best diversification. Correct answer is C. Very easy question. Okay, I'm just finishing off this LOS with a little bit from exactly from the CFA Level 1 curriculum in the book. And this is why I think it's important that you always review the curriculum 100% and see what's in there. Because sometimes there's just a little bit of a spin on things, and if you haven't seen it, you can get confused. But if you've worked your way through it once, it becomes quite easy. So we're very familiar with that correlation matrix. That last question was easy. But one of the things that they show us in the text is not a correlation matrix, but a covariance matrix, okay? So you've created a portfolio of two mutual funds, A and B, with 75% invested in A. So there's your Fund A and Fund B. Expected return on A is 20%. Expected return on B is 12%. And they want you to calculate the expected return of the portfolio. That's really easy. Calculate the correlation based on the covariance matrix, and that's what I just wanted to go through, because if you haven't seen this, it can be a little bit tricky. And then finally calculate the portfolio standard deviation. So this LOS is ending with kind of a nice review of several concepts. So the first thing that we're going to do is the expected return on the portfolio. That's just weight 1, 75% invested in A, times the expected return of A, 20%, plus weight 2, 25%, times the expected return on B, which is 12%. So we get the expected return of 18%. That should be very easy, okay? The next slide, we're going to look at calculating the correlation based on the covariance matrix. And then calculating the portfolio standard deviation is easy. We could do it right now, in fact, because we do have the covariance. Nevertheless, let's look at this covariance matrix and see what it's giving to us, because the numbers are a little bit different. So you've got A and A, you've got this 625. What is that? I said, aha, that's the variance. You know, I circled that in the green box, that's variance. And then what is the red circle? That's the covariance. It's not the correlation, it's the covariance. So that's the difference. We need to convert the covariance matrix into a correlation matrix, and a correlation matrix will have the correlation, not the covariance. So this is giving us covariance and standard deviation. We need to convert that table to a correlation matrix, okay? Okay, this was a nice little exercise because part 2, we wanted to calculate the correlation based on the covariance matrix. So we're given a covariance matrix, and we need to calculate correlation. So we know the correlation between A and B is the covariance of A and B divided by the standard deviation of A times the standard deviation of B. So we have the covariance from the covariance matrix, and this is what I said. You had to understand that when you're looking at A to A, that was the variance, and when we were looking at A to B, this was the covariance in a covariance matrix. Okay? So what we need to do then, covariance, which is given, we needed to calculate the standard deviation of A and the standard deviation of B, which is easy. That's just the square root of the variance. So the standard deviation of A is the square root of 625. The variance, we get 25. The standard deviation of B is the square root of 196. We get 14. So now we can calculate the correlation, covariance divided by standard deviation of A times standard deviation of B. So it's 120 divided by 25 times 14, and we get 0.34286, or 0.34. Now we can do our correlation matrix. Of course, the correlation between A and A is always 1, and between B and B is 1. But now we have the 0.34. We can plug it into our correlation matrix. The correlation between A and B is 0.34. Between A and B, 0.34. So not bad. It was just the little trick here was understanding that if they give you a covariance matrix, what are these two numbers? From A to A, that's the variance, and from A to B, that's the covariance. Okay? So then the final last thing was to calculate the standard deviation of the portfolio, and there's the formula again, weight 1 squared times variance 1, which we've got, plus weight 2 squared times variance 2, which we've got, plus 2 times weight 1, weight 2 times the covariance. And we've got the covariance. That was the 120. So we put our numbers in, 0.75 squared, weight 1, times 625, that's the variance of A, plus weight 2 squared times the variance of B, plus 2 times weight 1, weight 2 times the covariance. And if you just work your way through the math, you're going to get a standard deviation of the portfolio of 20.21%. So a nice way to finish this LOS. That's the last slide for this LOS. Thank you very much.